Welcome to the Learn to Code. Welcome to 30 days of Python. This is day 15, and today we'll be looking at Euclid's algorithm is an algorithm for finding the greatest common divisor of two numbers. In number theory, we use it to take two numbers. Like if you have 1,000 and 625, how do you find which number is greater? If you're Nigerian, you use HCF, and so for the rest of this video, I will be using the word HCF, which is highest common factor. So I will demonstrate it first before I go into more details. So step 1, you have a number. The number is 1,000. Second number is 625. Third number is, to find the remainder, we'll go to Python and we'll say 1,000 modulus 625. Now what is modulus? Modulus is the whole number remainder when you divide two numbers together. For example, if you say 10 modulus 3, your answer will be 1. If you say 13 modulus 2, your answer will be 1. If you say 13 modulus 5, your answer will be 3. So it's important you understand modulus before you can do Euclid's algorithm. So we know that 1,000 modulus 625 is 375. So we go back, write 375. Now the way to do Euclid's algorithm is for your step 2. You eliminate this 1,000. This 1,000 will go and you drag diagonally. So we say this will be 625 and this will be 375. We go back, 625 modulus 375, enter, that's 250. For step 3, you say 375, 250. Now, when you go to 375 modulus 250, that will give you 125. 125. Then this is 4, 250, 125. And this is 250 modulus 125, 0, 0, 0. So the algorithm stops and of your HCF is 125. Let's look at another set of numbers. Let's look at let me clean this off first. Let's look at 2,125 and then 115. The way you go about it is the same procedure. Say 2,225, 125. So that will give you 900. So you come here. Excuse me. 900. 1125. 900. 125. 900. I'll give you 225. This will be 900. 225. This will be 900. 225. The answer is 0. So the algorithm stops at step 3. So we can clean everything. And go to Python, create a file. Now what we're going to do is we're going to quickly write our algorithm. So step 1, and as we go we'll program it. So step 1, ask the user for 2 numbers. Step 2, test which one is larger. Step 3, make the bigger one m and the smaller one n. 4, set out to the remainder when m is divided by n. R is 0. The HCF is n. Stop and print out the value of set n to n. Step 7, set n to r. Step 8, go back to step 4. And that's the part where we did to use a loop. Now, if you remember day 14, on that day we talked about the while loop. So we'll be using a while loop here. I've already demonstrated how to solve Euclid's algorithm by hand. So because of that, let's just go straight to writing the code. So for the first number, we'll say first number goes to input is enter the first number. Second number goes to input is enter the second number. So for steps 2 and 3, we'll combine them with a test. So we say if second number is greater than first number, the second number first number temp. Now find the remainder. So we say remainder equals to first number second number. Now this case in our code, we would do a test. We say if remainder equals to 0, because it's a unique case where the user types in one number that is already like the modulus of the second number gives it 0. So you just quickly say equals to second number, because we want to use that as our as our answer. Then for the remaining part, we say else while remainder is greater than 0. So we'll do two things. So if you look carefully, you see that 1, 2, 3, 4. Step 4 is to find the remainder. We can do that within the loop again. So we say set sorry. Set so let's this thing come remainder is equals to first number plus second number first number equals to second number second number equals to remainder. So the last step is print. Say the HCF is first number. So let's run it. We'll save, excuse me, we'll save our work first. Probably save it on the desktop. Euclid and run. If you don't have any work first, this should work perfectly. Did we get an error? Okay, it's okay. Okay, so say 1, 2, 0, 0, 3, 4, 5, 6, 7. The HCF is 1, so it works. Let's run into those again. Let's run into those two values that we know we tested. So we say 1,625. The ATF is the last one, say 2025, 1125. The ATF is 225. So it works perfectly. Thank you very much for watching. See you in my next video. Don't forget to like and subscribe.